Hello, I'm Peter Glover. Today we'll do lesson 10 of the grade 9 series in the natural sciences, and we're going to be talking about magnetism. Now, magnetism is something that was discovered, we believe, by the ancient Chinese and at the same time by people living in what is now called Asia Minor, or used to be called Asia Minor, around Turkey, specifically near a place called Magnesia. Now you can see where the name magnet came from. And what those old people found, or those ancient people found, was a material which also got the name of lodestone. And it was a piece of rock which had one particular property, and a very interesting one. If you hung a piece of rock by a piece of string, it would orientate itself or move around so that it was always pointing in more or less the same direction. Now today we would say that it was pointing north or north-south along a north-south line. In those days they didn't have a word for north, but if you hung a piece of lodestone, it pointed in a particular direction, and it did that all the time. Now what was the use of this? Well, very soon people put it to the use of the people who did put it to the use, should I say, were travelers. Because if they had their piece of lodestone, they could hold it up and they could say, okay, I'm not quite sure where I am, but I know that if I keep moving along the line that this piece of rock is pointing, I will move in the same direction that I was moving yesterday. As I say, today we would say we'd be moving north or we'd be moving south in the opposite direction. But you could keep your direction constant. Now, let's have a look and see what the first question is from Asanda and her group.
Hey guys, we're back at Primrose High School. We've got lots of work and lots of fun to have, but before I say too much, my friends have only got one thing to say. Welcome back to Primrose High! Hey guys, we're back at Primrose High School, and in today's lesson we're going to be looking at magnetism, and to help me out with my first question is Quinton. What's up?
No, I'm fine.
You good?
Yeah.
Okay, so Quinton, I just want you to fill me in on what kind of things just drive you crazy about your school?
About my school? Well, actually my friends.
You enjoy hanging out with your friends?
I enjoy hanging out with my friends and playing rugby with them.
Okay, cool.
Yeah.
And what hobbies do you have?
Well, I play rugby, watch sports, and yeah, I listen to music.
Okay, nice. Which music do you like?
I like Afrikaans music, Afrikaans rock, and punk rock.
Who's your favorite?
Well, my favorite punk rock band is Simple Plan.
Simple Planning.
Simple Plan.
Simple Plan.
Yeah.
Okay, interesting name. I'll look it up. Why don't you go ahead and ask your question?
What exactly is a magnet?
Well, what is it?
Right, clearly that is the question we've got to ask. What is a magnet? And we've got to try and answer it too. Just before we do that, let's just consider what it is we're trying to aim at, what we think we're going to achieve in this lesson. We're certainly going to do some scientific investigations, very simple, but scientific investigations nonetheless, trying things out, observing, recording the results. We are going to develop some scientific knowledge, perhaps build on things that we already know and maybe refine our knowledge a little. And of course, I've already started talking a bit about history and the history of science and science as a very human endeavor. What exactly is a magnet? Well, let's take a look at some. Now, I suspect that there may be a magnet inside this round bit of plastic. I'm not sure what gave me to suspect that, but I'm suspecting it all the same. How can I test whether there is some magnet inside here? Well, it's actually very easy, because all I have to do, I don't have to take another magnet, but I have to take some material, perhaps like a little steel ball bearing, that is magnetizable. So this steel ball bearing is clearly affected by something that's lying inside this piece of plastic, and that something is going to be a magnet. So what I could do is I can pour a few more iron or steel ball bearings onto this magnet. Now have a look here. Did you see that when I dropped the, what was it, steel ball bearing number 6 onto these, the others all moved? Oh, not quite. There, you see, when I rearrange them, they tend to rearrange themselves a little bit. Look there. Now what that means is that not only have these things been affected by the magnet inside this box, but once they are affected, they actually become little magnets themselves, so that they can then affect another ball bearing in the vicinity. You see that as I move these around, so the ball bearings will also move. So what I'm doing here is I'm actually creating little magnets of the ball bearings. So let me pour on the rest that I have sitting in my hand, and you can see, in fact, when I hold this sideways on for you, you'll see something else that's happening, namely that they are stacking up on one another. If I hold this very gently, you can see that they've stacked up. If I turn it right over, they're going to fall over because the force of gravity will be slightly stronger than the magnetic force in that direction. No, there you go. There it is. You see how they've stacked up. Now they can only stack up if one ball bearing is affecting another ball bearing. In other words, the ball bearings themselves have become magnetized by the magnet inside this plastic box. So that tells us something about what is a magnet. A magnet is a material which will attract other materials that can be magnetized. Remember our little executive toy that we've got here, the magnet with the ball bearings. Now I've taken 2 of those ball bearings and removed them from the magnet. And you notice that these were all stacked up because they are magnetized. Now if I take these 2 ball bearings and I edge this one towards the other, and they don't behave as they should, but you see it's not having any effect on the other ball bearing. In other words, these ball bearings are magnetized when they get close to the magnet that sits inside the plastic container here. But they aren't permanent magnets themselves. Therefore, they don't affect one another when I place them close by. But when I take another magnet, I will magnetize them. And in magnetizing the ball bearing, creating that ball bearing into another little magnet, I get a magnetic effect between my permanent magnet and the magnetized steel balls. Now let's just introduce 1 or 2 other terms here very quickly. That has become magnetized and therefore it is attracted. It moves. Remember all the stuff we said about forces? Why does this move? Because there is a force acting on it. In other words, in this case, not a gravitational force, but a magnetic force. And just like a gravitational force, it is a force that can exercise itself through space, if you like. It doesn't have to be in contact to be exerted. Look. There. It's exerted across some space. And we say that that space around the magnet is affected by the magnet, and the magnet creates a magnetic field. So we'll come back to talking about fields again in just a moment. Now I hope that gives you enough basis to go and do the activity, which is to go and practically investigate how magnets behave.